Dear colleagues, hello everyone and welcome to my presentation. First of all, I would like to thank conference organizers for inviting me for this keynote talk. My name is Dmitry Ivanov. I'm professor for supply chain and operations management at Berlin School of Economics and Law. And today I would like to share with you some recent insights and observations with regard to supply chain resilience at the times of COVID-19 pandemic. So more or less we want to see what we know in supply chain resilience theory in managing such super disruptions, how the firms have operated through the pandemic times, where we had a success, where we failed, and most important, how to progress in terms of practical utilization of supply chain resilience knowledge and in terms of further theoretical developments in supply chain resilience theory. The key questions I would like to consider today is that when observing the COVID-19 pandemic and the firm's operations, one question is, have the established supply chain resilience measures helped the companies to cope with rapidly and adversely changed operational environment? Right. So the second question is, does the existing supply chain resilience knowledge provide a sufficient conceptual foundation, principle, and methods to help firms to survive and recover through the pandemic times? And the last question is, what are the main reasons of numerous supply chain collapses due to disruption propagations? So we want to see the ripple effects through the networks and how they can be mitigated in case of such super disruptions. And as such, I have divided the talk in two parts. In the first part, we will review the existing theory and discuss several examples of resilient operations management at the pandemic time. And in the second part, I would like to collate and review the existing knowledge in operations research in modeling the ripple effect in supply chains at different pandemic stages. Finally, I would like to discuss with you some suggestions for future research directions, which can be offered and discussed in light of new developments in supply chain resilience, such as supply chain viability, viable supply chain model, reconfigurable supply chains, and digital supply chain twins. And so we start with our first question: why should we care about risk, resilience, and ripple effects in the supply chain? To define supply chain resilience, it's usually considered as firms' capability to withstand, adapt, and recover from disruptions, to meet customer demand, and ensure the target performance. Since we put disruption as a central issue in managing of supply chain resilience, of course, it makes sense to define what disruption is. So disruption is an event which is not planned or anticipated, which interrupts material flow in the supply chain and may change structural design of supply chain for some period of time due to unavailability of some facilities, suppliers, or markets. Usually, supply chain resilience theory has been developed in light of such disruptions like natural disasters, labor strikes, legal disputes, most recently the epidemics, outbreaks, and the COVID-19 pandemic added a lot of new material, a lot of new inspiration and challenges to supply chain resilience theory, and this is what we want to discuss today, right? So put simply, especially for those of you who have not researched or dealt much with resilience, we can understand resilience as a kind of immune system of a supply chain, right? So each of us has an immune system, and immune system, it's about to protect ourselves against some external virus, right, which is a risk in terms of supply chain, and to recover once we have a disruption. So similar to supply chain, right? So resilience as a kind of immune system in the supply chain, which is designed to absorb external risks, like viruses in a human body, and to recover in case of performance degradation and structural changes in the supply chain. The second terminology that we will use throughout the presentation is named ripple effect. So ripple effect is something which refers to disruption propagation and associated changes in the supply chain structures, demand fulfillment, as a consequence of a severe disruption. Right? This picture nicely illustrates the key idea of the ripple effect. If we have, say, a disruption at a second-tier supply in the supply chain in one region, and due to complexity and globalization of many supply chains, this disruption is difficult to localize. In most cases, disruptions are propagating downstream the supply chain, interrupting normal operations at subsequent echelons of the supply chain and reaching quite far away downstream, even towards assembly plants and markets. Right? So, and when dealing with the ripple effect, we usually analyze three areas: performance impact, right, to see how our main performance indicators like service level or annual sales are affected or would be affected by these changes, negative changes in the supply chain structure. What should we do in order to stabilize our inventory control policies, production ordering policies, a kind of process level analysis? And then what should we do at the structural level to recover the supply chain? So it is a multi-level analysis which includes network perspective, process perspective, and control perspective. So, and in order to understand ripple effect better, perhaps we can contrast it to the bullwhip effect, right? I think many of you are familiar with the bullwhip effect, which is, propagation of a small variation of demand at a couple of retailers upstream the supply chain, resulting in even greater fluctuations in order quality and production quantity at manufacturing plants and suppliers. Bullwhip effect is usually considered as a kind of high frequency, low impact event, right? And ripple effect is different. Ripple effect is a kind of disruptional risk, which is low frequency, high impact effect triggered by severe disruption in supply base or in demand. Through the pandemic, we have seen a lot of ripple effects. You can take a number of examples, starting from the very beginning of the pandemic in January and February, when production has been stopped at many suppliers in China, and the subsequent closing of ports resulted in multiple production stops at original equipment manufacturers, at assembly plants. This resulted in unprecedented vulnerabilities in lead times and order quantities, disruption of the whole networks, and severe demand fluctuations. As such, the ripple effect has been seen as one of the strongest stressors to supply chain resilience at the COVID-19 pandemic times. There are some data which has been collected in April-May 2020, which show evidence of huge vulnerabilities in lead time, which have been increased by about 20%, and at the same time, normal capacity utilizations dropped by 50%. The pandemic, it's a very specific disruption, unlike any seen before. At least we can identify three major distinguishing features of a pandemic, which define it as a very specific type of supply chain vulnerabilities. First, pandemic has a very long-term existence of disruption and unpredictable scaling of disruption. In contrast to, say, conventional classical disruptions, which, like, for example, earthquake or tsunami, which hit a supply chain at a time and then disappear, and then we should recover, right? So pandemic has a very different disruption profile. It begins gradually, so it is not the full impact from the very beginning. The impact is quite low at the beginning, and actually we have time to prepare in many cases, right, if we anticipate a pandemic. However, this disruption exists very long. It's a kind of external system of some exogenous dynamics which influence our supply chain. So another system for a long period of time, a kind of system in system situation, not like a single event which has instant impact and then disappears. And such situation is definitely an understudied area in the ripple effect. The second specific feature is simultaneous disruption and epidemic outbreak propagation in the supply chain. This is also a very novel setting for supply chain resilience research, right? Because in the pandemic we have seen simultaneous and sequential openings and closures of supplies, facilities, and markets in different regions in the world. And finally, the third specific feature of a pandemic is simultaneous severe disruptions in supply, demand, and logistics infrastructure. So it is not like we have disruption in only one part of the supply chain. Disruption in the pandemic happened in all parts of the supply chain and even in the markets. And they can happen simultaneously, they can happen sequentially. So these timing effects are very interesting, very specific, and definitely represent a novel complex setting, problem setting with both forward and backward disruption propagations in the supply chain. The first observation, how the firms have reacted to the COVID-19 pandemic, how they can change their operations, show that different resilience capabilities have provided different success and have been used differently. So usually we have two types of resilience capabilities: redundancy and agility, flexibility, right? So redundancy is like inventory or some backup suppliers, something which can be activated in case of a disruption. And agility, flexibility, is another part of resilience capabilities which aim at adaptation to current situation. And what we have seen through the pandemic times is that redundant resilience capabilities have not really helped much firms to survive through the pandemic. All right, so it can help at a short term if you have, say, disruption which lasts 3-4 weeks. Because, for example, in automotive industry, many processes are organized just in time, and inventory was available for a period of, say, maximum 30 days. A pandemic was not over within 30 days, right? It is still with us, and it is a very long disruption. Moreover, backup supplies and factories have been located in different regions, and due to different timings of factory shutdowns and quarantine measures, lockdowns in different regions, regardless of you have global or local supply chain, these resources have not been activated or were not able to be activated due to chaos in the supply chain and due to many disruptions in different parts of the world. More positive experiences have been observed in agile part of resilience, with agile capacities, with data-driven real-time visibility system. Right? For example, agile capacities enable firms to repurpose their supply chains. We have seen a lot of examples how luxury goods manufacturers have completely transformed their operations to manufacture urgently needed items like PPE, personal protection equipment items. We have also seen how the automotive companies have changed from car manufacturers to ventilators and hospital beds by collaborating with local manufacturers. So this is perhaps the first important insight that we can formulate as preliminary observations. Adaptation capabilities play the most crucial role in managing the supply chains under pandemic disruptions. So far to the first part, to the introduction to main terminology and practical applications. And now we want to take a closer look at operations research topics and to see how the existing modeling methods can support decision-making in pandemic times and what are future research areas. We will follow classification provided by World Health Organization for pandemic. This classification separates pandemic dynamics into 5 areas, which are anticipation, early detection, containment, control and mitigation, and elimination. And in the next slides, we want to see methods from operations research which have been used for ripple effect modeling across these pandemic stages. We also want to see managerial insights which can be deduced from the existing operations research method to cope with the ripple effect, and how this knowledge can help now at the times of the pandemic and also in future. One can expect that super disruptions can come to us again, and of course it is the most important crucial task now to learn as much as possible from the current pandemic and to be prepared better for such super disruptions. Operations research methods for coping with the ripple effect can be divided into 3 areas, which are network and complexity theories, mathematical optimization, and simulation optimization. Network and complexity theories include application of Bayesian networks, reliability theory, Petri nets, and Markov chains, and complex adaptive systems to ripple effect and resilience analysis. The mathematical optimization methods which have been used are mixed linear programming, stochastic, and robust optimization. In simulation, we can see papers which deal with ripple effect using agent-based simulations, discrete event simulation, and the systems dynamics. So we have recently published a paper which extensively deals with different methodologies and different technical issues of each of these methods and how it has been used for ripple effect analysis. That's why I will not go into detail now due to the limited time of the talk. And I refer to the paper indicated on this slide, where you can get much more details. Most interesting and most important now to me is that we analyze and generalize the theoretical outcomes and managerial insights from these studies. So if we look at the studies of the network and complexity level, we can see that this research tries to find some associations between network structures and risk propagation. It also looks at identification of critical network elements and modeling of interdependencies in the supply chain, including state dynamics and assessment of robustness and resilience of supply chains to the ripple effect. Right? Then, if we break down discussion to the process level, mathematical optimization has mostly been used. Right? So this part of research looks at optimal reallocations of supply and demand in the disrupted systems, at optimal reconfigurations of material flows according to disruption propagation scenarios. It also helps to model impacts of the ripple effect and structural dynamics on some performance indicators like service level and costs, and to optimize reallocation of supply and demand under conditions of the ripple effect. And at the very detailed level, if we continue our discussion in terms of control, the simulation methods have mostly been used to understand dynamics of the supply chains, right? To understand the impacts of disruption propagation on inventory dynamics, to observe time-dependent effects of disruption propagation and supply chain behaviors, elements of supply chain behaviors at different facilities, and also individual behaviors of firms in the supply chain. So we can say that there is a kind of broad spectrum of research, and this range covers different areas, right? So network level, which looks at large-scale complex systems. Then we can add more details in the process level when we see at process control, production planning, distribution planning, and finally we look at so inventory policies, production ordering policies, to understand behaviors of supply chain at the very detailed level. Each of these studies, each of this group can help deduce useful managerial outcomes. For example, the studies at the network level help supply chain managers to identify possible scenarios for disruption propagations of different severity, depending on the degree of risk aversion of supply chain management. These methods can also be used for stress testing of supply chain design prone to disruption risk propagation. And such methods can also be used for identification of critical suppliers and facilities. Finally, we can also apply network and complexity methods for adaptation of supply chain design, for example, using complex adaptive systems according to changes in the system environments. At the process level, we can provide to practitioners a lot of useful methods like stress testing of supply chain production distribution plans within some disrupted networks, analysis of different contingency and preparedness plans, and these methods can also help to select optimal recovery plans in the supply chains. And simulation studies can be used for analysis of disruption propagation in dynamics. They help understand impact of changes in production and inventory control, and understand different operational policies under disruptions during disruption period and also in the post-recovery period, for example, to identify so-called disruption tails in the supply chain, which are very dangerous if we do not change inventory control policies in the post-recovery period. Well, this is one specific topic, and I would refer to literature with regard to disruption tails to understand this effect more detailed. I would like to summarize now some insights, some outcomes of this research without going into the details of the simulation, which are described very detailed in the paper, which is indicated in this slide. So what we have observed through the simulation of different scenarios, we looked at scenarios of different severity of a pandemic, if pandemic can be localized, say in one region, or pandemic propagates to different regions, resulting in lockdowns and shutdowns. We looked at different duration of lockdown periods, and we also looked at different timing of lockdown periods in different regions. So this created about 40 scenarios, and analysis of the supply chain performance reaction to these scenarios allowed us to identify some observations. So the first observation was that supply chain reaction to pandemic depends on the timing and scale of disruption propagation, so the ripple effect, and also on the sequence of facility closing and opening at different supply chain echelons. Then we have observed that a combination of velocity of pandemic propagation, the duration of quarantines and lockdowns, and degree of demand decline significantly impact supply chain performance. In other words, it matters if all countries or many countries introduce lockdown measures at the same time, or if this happens with some delays in different regions. This can have great effect on supply chain performance and should be considered by supply chain managers in advance when preparing recovery strategies. And the last observation was that different components of a supply chain can be affected sequentially or simultaneously. Under components, I mean, different elements of the supply chain network, like manufacturing facilities, distribution centers, logistics companies, and markets. And in some settings, there can exist overlapping time windows in the lockdowns and shutdown methods, which can lead to literally paralyzing of supply chain networks when critical facilities and markets are affected at the same time, or even in a sequence with some overlapping time windows. So far to this part, and finally, I would like to bring to your attention some future research directions which extend the existing state-of-the-art in supply chain resilience, and where we can expect some further developments which are relevant for theory and important for practice. I would like to focus on 5 future research directions: the digital supply chain twins, the viable supply chain, intertwined supply networks, multi-structural dynamics, and reconfigurable supply chains. First of all, the pandemic has clearly shown that companies with visibility systems, with supply chain digital twins, have performed much better and have shown much higher resilience as compared to firms which have not used digital technology. That's why the first very important future research direction is to understand how digital technology, additive manufacturing, industry 4.0, sensors, blockchain, how all these technologies can be utilized to improve resilience. And there are a lot of potentials, for example, looking at supply chain digital twins. So a digital supply chain model which represents a physical part with actual transportation, inventory, demand, and capacity data can be very useful for planning and real-time control decisions if we have severe disruption and need to understand the impact of these disruptions, by collecting different risk data and understanding the impact of disruption on supply chain using simulation and optimization tool integrated with data analytics approaches. Right? And such digital twins can be built using supply chain simulation and optimization tools. An example, like in our research, we have used the any logistics supply chain simulation optimization tool, which can be integrated with an external system like risk data systems. And by that integration, we can actually map risk data and supply chain data, which can allow us to identify if some disruptions in real time, which I identified in real time in the risk system, and then we can map this risk data with our supply chain design and see if we have facilities, if we have suppliers, if we have logistics infrastructure in the disruption region. And if these disruptions are relevant for us, we can use simulation optimization for stress testing of supply chain designs, for selection of recovery plans. And another important application is that we can analyze performance. We can use supply chain models and digital twins to simulate disruption propagations, to simulate our response to the disruptions in terms of recovery impacts, and to see possible and real performance impacts. Another important area is viable supply chain. Supply chain viability is seen as the next direction, next step in resilience theory development. And the importance of this part of this area became evident through the COVID-19 pandemic times. So viability is seen as the ability of a supply chain to maintain itself and survive in a changing environment through a redesign of structures and replanning of performance. So a viable supply chain model is based on adaptable structural supply chain designs for supply-demand allocations and, most important, establishment of adaptive mechanisms for transition between different supply chain designs. Usually, before the pandemic, the companies have mostly focused on efficient or responsive supply chain design, right? And considered, for example, random uncertainty like demand fluctuation as a possible stressors to this design. Many companies have also utilized resilient supply chain designs as a response to natural disasters, for example, which considered some, resilience capabilities like risk inventory or capacity buffers or backup supplies. However, one element was missing, and this element became very evident through the pandemic, and this is survivable supply chain design. Through the pandemic, we have observed that the firms needed to repurpose their supply chain, to redesign supply base and logistics, to localize many processes. This level of survivability, it's something which became evident for the pandemic time, and now with all these three levels, agile, resilient, and survivable supply chain design, we can define a new kind of supply chain understanding, which is a viable supply chain model, which allows to survive, which allows to maintain operations continuity with regard to different stressors. Random stressors like demand fluctuations, and very severe, very deep uncertainty like natural disasters and even global pandemics, right? So that's more important to survive, to maintain business. And in order to maintain business, we need to ensure survivability of our supply chains. So this is something new which came from the pandemic times and which can be seen as a research direction, right? So this difference can be very nicely understood when we take example of a car. So why we are driving a car? We are driving a car in order to get faster to some destinations, right, at short lead time, in operational view. However, strategically, we are driving cars in order to stay mobile, right? And for example, a car can break down. So this is a disruption, right? Then we analyze what happened, assess impact of this disruption, and then we need to stabilize. So we are driving to a service station where our car will be repaired. So this is recovery. And then we get it back in an old or maybe even improved or equivalent stage. So this is classical resilience profile. However, what happens if a car cannot be repaired anymore? So in this case, we need to adapt structurally, right? We can start using public transportation, or we can buy a new car, but anyway, it will be new normal for us, right? It is not more about to returning back. It will be new normal for us, and we need to organize our operations as this new normal and recover performance after that. So this is what we understand under viability. So very close issue is to viability, it's intertwined supply network. Now, only a few cases supply chains can be clearly separated from each other. They are usually intersecting. Firms can change their behaviors, their roles, buyers and suppliers. The firms can be buyers and suppliers at the same time. And as such, if we look at the intertwined supply network as object of optimization, it makes sense to develop ecosystem view of the supply chain, right? For example, suppliers in automotive sector can be at the same time producers of valves for respirators. All right, so you have two intertwined supply networks where the same firm changes behaviors. So that's why I encourage to look at the intertwined supply networks as an object for supply chain resilience management. There is something named multi-structural supply chain dynamics. The key idea here is that supply chains are not only organizational systems, right? Like many research papers position the supply chain. Supply chain structures are different, right? It's not only a network of suppliers, manufacturers, and distribution. It's also a network of technology. It is also a network of information. It is also a network of finance, network of product structures and processes. As such, if we have disruption in one of the structures, it immediately affects other structures. That's like in case of COVID-19. If you need to repurpose your supply chain from car manufacturing to ventilator manufacturers, your organizational structure will change, your technological structure will change, your information structure will change, your product and process structures will change, right? So that's why it is also very interesting research direction to look at supply chains and their resilience from the perspective of multi-structural dynamics, right? And to finalize this discussion, another newly emerged framework is the Reconfigurable supply chain, which looks at advanced utilization of digital technologies, sustainability, resilience, and efficiency in designing and managing the supply chain network. Right? So reconfigurability is an important part of supply chain viability. So, dear colleagues, to summarize this presentation, we were mostly looking at risks, resilience, and ripple effects, which are major determinants and major stressors to supply chains and seem to be very important for new normal, which can be increasingly shaped by uncertainty. The existing theory offers a large variety of methods to support supply chain adaptations and reconfigurations, methods at the network level, mathematical optimization level, and simulation levels. However, the pandemic is definitely a very new and very specific type of supply chain risk and disruption, say super disruption, which clearly shows that even if resilience can be costly, a missing resilience can be fatal. And finally, we have identified future research areas like advanced utilization of digital technologies and digital twins for managing supply chain resilience. Then we looked at supply chain viability and intertwined supply networks, which motivate us to think beyond a narrowed resilience understanding as just a recovery of some critical capabilities or economic performances, and organizing debates toward long-term viability and more complex supply chain networks. In this sense, there are relevant frameworks like Reconfigurable supply chain or LSN supply chain framework. We have not considered it much in presentation, but mostly LSN means lean resilience, right? So organizing resilience in an efficient way and using resilience for value creation, all right? And very relevant topic to viability is open system view of resilience, and all this creates a very exciting, very motivating, insightful agenda for future development of supply chain resilience theory and practice to create knowledge about super long disruptions. So thank you very much, dear colleagues, and I will be happy to discuss with you about this presentation. Thank you. Some of the recent results have been summarized in our recent book, Global Supply Chain and Operations Management, which is a textbook containing specific chapter on supply chain resilience, and also 2 books on the ripple effect and supply chain structure.